Test, test. There we go. Right. Now let's see if I can get the pointer to work. That should be easy. Ah, apparently not. There we go. Finally, back in business. Okay, so as Emily said, yes, I'm going to talk a bit about one of the implementation projects we have recently started. I'll say here in Geneva, technically in the town of Geneva, but right up the stream from here, as we would say, Marsh Creek, one of the two principal streams that run through the city of Geneva. Does this have a, whoops, now what did I do? Okay, there's the pointer. And I'm colorblind, so that's definitely not working. All right, so we'll just do it the old fashioned way. Marsh Creek, right here, north side of Geneva. The drinking, well, we'll go through it in a minute, but as you can see by the image, this was taken by Professor John Halfman approximately 2 years ago on one of our disturbingly frequent intense rain events that we see more and more around here these days. I don't know if you can tell from the image, but we've got lovely brown Seneca Lake here to the left and the even lovelier and browner Marsh Creek outflow coming into the lake. A regular occurrence now with these intense events. And also, as you can imagine, because of what the water looks like coming in the creek, the water going into the creek isn't much better and flooding, particularly on the old infrastructure that was designed around historically 25-year projected storm events isn't up to handling what we see nowadays in a lot of places. This along Carter Road. So that's the issue we're trying to address at the most basic level. Again, to get us a little better oriented, here's the outflow of Marsh Creek here at the waterfront, just north of the Welcome Center. This is the principal drainage channel for Marsh Creek. The northern branch, we'll say, is actually in pretty good shape. And as you can maybe see from, I don't know if this thing's working or not. Can people see this? Okay, sorry. I'll just have to guess it's where I'm pointing it at. So from this stretch there, oh, now I can see it. Fantastic. To about the railroad grade, really nice, intact, lovely wooded floodplain. And we actually have a preserved flood retention area here on the other side of the track. So that branch is in pretty good shape despite the historical development in the area. This branch is a different matter, and this is where we're focusing right now. One of the principal reasons this branch presents a challenge is, so this is a contour map. The further the contour lines, the flatter the terrain. So up here, up here is where the Cornell Ag Experimental Station is, flat, good agricultural land. And then as it drains down, we get these gully formations. The topography really starts to drop away in elevation, flows can begin to collect and focus energy in particular spots. And we get these drainage gullies and erosional features on the landscape. To address some of this, there's a couple different holistic approaches multiple agencies and groups are working on. So in the southern portion, the town of Geneva and the Ontario County Soil and Water Conservation District and Wallace Solar Development Group and a local farmer whose name is escaping me, put in a series of retention ponds last year. At least one of which, correct me if I was wrong, if it was more than one, was funded through Pure Water's sediment nutrient reduction program. So over 1 million gallons of storage combined from that so far. And then on the north side, this parcel is currently going under plan and review by the town board for low income housing development, but the town of Geneva has really good local laws in terms of stormwater. So the development of that parcel, if planned and pursued as on paper it currently is, will actually see a reduction in water volume from that parcel despite it being developed. So we are looking at, with this project here, a space right in between. So let's see if it starts. So as Emily mentioned, in 2022, the farmer who owns the parcel that's being developed here on the left is low income housing development. He gifted this 22-acre parcel adjacent to it to the city. It's largely floodplain area. There are a identified wetland area on here as well. He historically used it as an agricultural storage area. So debris that was moved from the field, some tires, some trash. There's clear, must have been dumped, like used as a local dump for glass and metal a long, long time ago, probably before he ever owned it. So not exactly the most appealing parcel for development or other uses, right? So he just gave it away. Benefit to us though, because for what we're trying to do, it's perfect. The topography, as I said, it's at where the slope in the stream begins to level out. We've got some nice topographical features that we'll go into a little bit here that give us a lot of opportunity to do water quality improvement, both volumetrically and chemically, we'll say. So like nutrients, pollutants, sediment. So before I want to go any further, of course, how do we pay for this? So this project is being funded principally through the Department of State Local Waterfront Revitalization Program. They're providing 75% of the cost for this initial phase of the project. The remaining 25% has been provided through a number of local means. Myself, the town of Geneva provided cash, volunteer time that I'll get into. Oh yeah, I already have it listed there, so it's not a surprise. HWS students provided some volunteer time here that I'll talk about. And because we are in what is identified as a disadvantaged community, I actually have to correct myself. It was a 15% local match. So that helped us get to where we needed to be monetarily. Okay, so we just started here in January of this year. So the first step is to kind of glean what we want to see this parcel develop and look like, right? We have some basic overall goals for improvement, but there's a lot of opportunity. It's kind of a blank canvas. What do we want this parcel to ultimately look like? What function do we want it to serve? To kind of get at that initially, we worked with Professor Beth Kinney and her environmental capstone students to kind of get some initial feedback from people who we presumed would be the heaviest users of the parcel. So we canvassed, we'll call it canvassed, over 500 homes within a 1 mile radius of the park to kind of get an initial idea of what people envisioned what we could use this space for. So this is just some of the initial findings so far. I will say that was just an initial effort. This survey is still accurate. If you're interested in providing your input, it'll be active for the rest of the year, and we'll continue to collect that information to help us inform design as we move forward. But so principally, you can see the uses here, 78% exercise, 72% relaxation, 50% just as a escape from the busy urban landscape that's Geneva. Some of the features that they mentioned that they wanted to see in place were trails, trash cans, park-in, seat-in, shade features, sort of mixed on more traditional urban park features. Sort of no one asked for a pickleball court, thank goodness. I'm glad that didn't come forward. No bathrooms, no like sports features. So I don't think people envision it as, McDonough Park, right? No baseball field, no like hard surfaces, right? It's about a natural park feature, kind of similar to maybe Kashan, right? If you're familiar with that on the southern side of the town. As far as environmental features that they might want to see incorporated, things like rainwater harvesting, bioswales, native plants were the most common requests. We also, the students also canvassed at Mission Zero, which was, I always get them backwards, Earth Day or Arbor Day, can't remember which one it was, not too long ago in April. Got a lot of good response in person, actually. So they put a couple ideas on paper, just so that when people came by, they get an idea of visually of what this might look like. So the students broke, I did it again. The students broke it up into kind of two concepts. One, a more urbanized feature where you'd have a lot of hardscape, like light-in, paved trails, things like that. And then a more rural park, very low development impact, very like nature-based development. And perhaps not unsurprisingly, given what we also saw in the surveys, wide, massive preference for the nature-based development. And also some of the features that people provided they wanted to see in there Interestingly, biospheres weren't that big on the in-person stuff. The most common features were bloom gardens and a water flow playground, which was exciting to me because that's something I specifically had envisioned when we put the grant in there. Yeah, so slightly different, but largely on the same path from what we saw from the survey so far. Of course, you can propose whatever you want, but you actually have to do an analysis of what you can do. And that's where the other side of this comes into. So we've also started collecting a bunch of landscape information that can inform what we can and cannot do in that space. Some things to consider. I already mentioned that there is undelineated wetland, as many of you know, or maybe you don't know. New York State recently changed the wetland rules throughout the state. So we are uncertain exactly where the limits of this wetland are going to be and how that might impact our project now. But that is one thing we will have to address as we move forward. We have a utility corridor that you may have seen in that overhead video. There is an electrical transmission line on the northern portion of the border through this red area here. So that will limit things like you can't plant a American sycamore tree that's going to grow 175 feet high, right? But we can put wetlands under there. We can put low development like a parking lot under there. So that's something to consider as we develop the space. Some other things, there's an existing drainage easement from the Woodland apartment complex just to the south. So we can't disturb that in case they ever have to put in a drainage feature, but we can incorporate our design to offset that drainage in the future for whatever to become necessary if they were to expand. And then you can see from the topography here, again, going back, close lines are significant slope changes, far lines are flat areas. You can see we have, I wish I wasn't colorblind. You can see we have these for the area, steep slopes here, right against a very broad, flat floodplain that if the stream were not incised 6 feet down below the surface elevation, the water could get into, store, and sequester nutrients and water and reduce flooding. That's what we're trying to access. That's the goal here from the water quality perspective side. Another thing, because Cornell is the principal upstream feature that's draining into this stream, and there are tile lines draining back to, we don't even know how long ago. We find pieces of clay tile all over the landscape in the stream. So we don't know what the connectivity of that is and how it might be impacting the hydrology we see in the stream. So we are gauging that to try to ascertain if our initial modeling of the high stream hydrology is accurate, and if it's not, how will that impact our design standards in terms of what volume of water we want to try to target and capture. As well, we have an enormous amount of invasive species here, just about all the commons ones you will see in New York State. We've got, I'm not a biologist, so I'm horrible at this, but I think this is mugweed directly into knotweed, directly into it's escaped me, autumn olive, right to the stream, just a blanket of it. Bruce, you can help me with that. So yeah, we got a lot of that to consider too, and how we fight that and develop it and how we manage that going forward as well. So ultimately, what we want this thing to look like, and largely what the question is from the water quality design perspective is, do we want to focus on dissolved retention and function within the stream? Like, is what we see coming from, is the impact of the landscape above the parcel from the Cornell Experimental Station creating a situation where we need to focus on volumetric storage and explore options like this, where our principal design goal is to capture and store as much water as possible? Or is those features actually providing some peak flow reduction that we're not accounting for presently? And our goal should be more about in-stream habitat creation, because a lot of people, as I mentioned to Mark a little earlier, I had an epiphany earlier today. Streams can sequester an enormous amount of phosphorus if they're functioned properly. So maybe we don't need to focus on volumetric. Maybe we can just allow restoration of the natural stream function to optimize our design goals. So that's kind of the design question we're trying to get at as we move forward. Okay, so we're in the early stages here. We're only on month 5. A lot of this work, because we are operating in a floodplain, will have to be done by a professional engineer. So the first step after this meeting, in about 2 weeks, we're going to be releasing an RFP to hire a professional engineer and landscape architect to begin analyzing the information that we're collecting and actually create a model that will recreate the flow conditions that can then inform a full-on design of the system. We'll look at both of those approaches, and we'll also incorporate the impact on, the more recreational and educational features and try to develop 2 alternative concepts that we can come back to you folks, to other people in the community, to help then select what the preferred alternative is. Once we have that preferred alternative, we'll then begin the final design phase. So you can think of like blueprints, basically. And then that'll allow us to go into the permitting process and ultimately construction. This is phase 1. The program allows for design and engineering in phase 1. And then once you've gone through the process, you can apply again to the same program for phase 2 to actually implement what you're proposing. So long timeline is all of these sort of public projects on waterways. These are slow, but on a cost benefit basis, it's worth it, right? This will probably take a 5-year process, but once in place, it'll be functional for decades. And again, it's not just water quality, right? It's also a community resource beyond just that. So that's the goal here. We hope this is just the first time you'll be hearing about it and you'll come back and participate in community engagement. By all means, again, the survey, please provide your thoughts on what you might want to see. And I'll stop there.
Okay, awesome. Thank you, Ian. So we're going to have time for questions and answers at the end. So we're going to make all of our presenters come back up, and then we can ask them all sorts of questions. So just so that we can keep moving on through, we'll do that at the end. Okay, so next up, let's see here, we have Lexie Davis, the Great Lakes Water Resources Scientist with New York State DEC Finger Lakes Watershed Program and Great Lakes Program, and with the New York State Water Resources Institute through Cornell. And she is going to be speaking to us about harmful algal blooms. She is I said it again, resources scientist for DEC and with Cornell. Her current work is focusing on monitoring and researching watershed issues in the Great Lakes Basin. Her presentation is going to provide an introduction to harmful algal blooms, from exploring their causes to discussing the risks to human and environmental health. It will also highlight New York's holistic approach to HABs by summarizing their monitoring programs, research initiatives, and mitigation strategies. So step right up, Lexie. And she wore green because she's talking about HABs. Okay, do you think? Forward. And then in the way it moves. I think you're good. You can, yeah. Thank you.
I'll tilt this down a little bit. It's big. Can you hear me okay? Do I need to move it down a little bit more? We're good? Okay, perfect. Thank you. So thanks, Emily, and thank you to Seneca Lake Pure Waters for hosting this event and for being a truly amazing example of a great partner. It's really because of organizations like Pure Waters that we are able to work together to keep our Finger Lakes as wonderful as they are. So thank you so much. And thank you for having me today to speak about harmful algal blooms, or HABs, as you may call them. So for my presentation tonight, I will give an introduction to what HABs are, go over some HABs mitigation and research happening in New York State, and briefly go over what we are thinking about looking forward. Okay, so let's kick things off with a bit of background. So, the state, we love acronyms. So HABs, harmful algal blooms, the H stands for harmful, as they have the potential to produce toxins that may have health implications, and they can impact the economy by limiting recreation ability, negatively affecting the aesthetics or looks of an area where they are present, and potentially cause harm to the ecosystem. For example, by a bloom die-off could depress the dissolved oxygen in the system, and this could result in fish kills. The A is for algal. And this is kind of misleading because freshwater HABs are not truly algae, but they refer to cyanobacteria. And B is for bloom, which refers to the density of the organism as a proliferation or large group of cells in dense concentrations. So to compare and contrast, algae are single-celled plants that have chlorophyll, which provides that green color, and they photosynthesize, meaning they use sunlight to make food from carbon dioxide and water. And these are normally not harmful, but on the other hand, cyanobacteria are natural. They're very specialized, and they are very competitive ancient bacteria that have been present for billions of years, and they are able to regulate their buoyance or their ability to float or fix nitrogen in order to fill a specific niche. And they have other pigments in addition to chlorophyll, so they can present other colors other than green, which is why you may have seen or heard of them being referred to as blue-green algae. And under the right conditions, these can form harmful algal blooms or HABs, which produce toxins, which we will take a look at next. So there are lots of different toxins that can be produced, but I am going to just focus on a few of them today. So the first are microcystins. These are liver toxins that are produced by cyanobacteria such as Microcystis. This is what is most commonly observed in New York. And next we have anatoxins, which are nerve toxins, and these are produced by cyanobacteria such as Dolichosperma, which are also common in New York. And these are known for their ability to fix nitrogen. So it converts nitrogen into a different form, such as ammonia, using a catalyst called nitrogenase. So now some cyanobacteria produce microcystin and anatoxins some of the time, but all cyanobacteria have lipopolysaccharides, which are endotoxins that are skin irritants and allergens. So all that to say, there are no visual cues that toxins are present or what toxin is present. So there can be a bloom that is visually intense, but the toxins may not be present. Or there may be a bloom where it doesn't look that bad, but toxins are present. So this is why it's really important to know it, avoid it, report it when you see anything that looks like a HAB. And of course, stay out of the water and keep your dogs out of the water too, please. Okay, so another piece of complexity of harmful algal blooms is that there are some significant variability that can occur both seasonally and within water, which is normal and to be expected in lakes. So for seasonal variability, it is important to look broadly at the ecosystem picture, as cyanobacteria aren't the only things swimming around in the lake throughout the year. So in the figure on the left, we see the abundance of phytoplankton throughout the months of the year. And you'll notice that there are different species throughout the year that peak at different times. So diatoms dominate in the spring and fall, which leaves an opening in the summer for the blue-greens to be dominant. So this makes sense because this is when we really see HABs on the Finger Lakes, but it is important to note that blooms have been documented in New York State from April through January, and climate change will continue to widen the window of when we expect blooms to occur. There are a couple of things to consider for within water variability. So the graphic on the right depicts how blooms are generally believed to form. Starting at the top, organisms are dispersed throughout the water body, and then at a certain point in the growth cycle and under the ideal conditions, they accumulate at or near the surface. And then with sufficient wind or wave action, they move but do not disperse or remix the cells, so they can accumulate along the windward shore or where prevailing winds are directing them. So what can start as a small thickness of cells over a big enough area and concentrated in one location can quickly become a large visible bloom along the shoreline. So you might be asking, why are these HABs happening? So as part of the 2018 HAB Research Initiative, a statewide and series of lake-specific analyses took place to determine characteristics which most closely associate with HABs. So this logistic regression analyzes parameters and shows that phosphorus, dry-scented mussel presence, lake fetch, which is the length of a lake's surface that the wind can blow uninterrupted in a single direction, and the compass orientation of the max lake fetch were significant parameters that are closely associated with the presence of HABs. So all of these things, coupled with sunlight, calm conditions, and warm temperatures, makes for the perfect conditions for a harmful algal bloom to occur. And it's important to note that some model parameters cannot be managed. So phosphorus is specifically called out with the asterisk because it is now the only factor that we have some control over. So like I mentioned in the previous slide, the best case scenario for a HAB is high temperatures, high light, and high nutrients. But HABs, as we know, have been present in low nutrient water bodies, such as the Finger Lakes too. So historically, HABs have been associated with high nutrients, with total phosphorus levels being greater than 30 micrograms per liter. But HABs and high nutrients are not always neatly linked, as evident by the HABs presence in the low nutrient lakes of the Finger Lakes, for example, with some of the Finger Lakes having average summer phosphorus values much, much lower than 30 micrograms per liter. I also want to note that land use is not directly a determining factor of harmful algal blooms, as is shown on the map. So the green color shows the forested area of the watersheds, and the yellow color shows agricultural area. So although most of the watershed of the Hemlock and Canadice Lake watershed is green or forested, and Seneca Lake's watershed has a lot of the yellow or agricultural area, both of those lakes experience harmful algal blooms. Okay, so now that we have some background, let's dive into some mitigation and research that has been done or is happening in New York State. So New York State has a long-term strategy with a holistic and integrated approach to harmful algal blooms with several pieces in focus. So the first is watershed management through monitoring, clean water planning, and pollutant reduction strategies to address long-term controllable causes. The next is funding projects to reduce the occurrence of harmful algal blooms through programs like the Water Quality Improvement Program, or WQIP, and the Non-Point Source Planning Grants, or NPG. Next is research of harmful algal blooms and their causes with a focus on prevention, mitigation, monitoring, and modeling to understand causes and we have available the New York State DEC HABS research guide that highlights specific areas of interest for research. And lastly is in water body mitigation through development, implementation, and evaluation to help control bloom size and formation. And I will get into these a bit in the next slides. Okay, so DEC has a lot of different monitoring programs happening. So all of the data collected with all of these programs is available on the Division of Water Water Quality Portal, which is a screen capture on the top. So the red dots indicate where stream sampling data has been collected. The blue dots indicate where lake sampling data has been collected. And this is updated yearly, so you can find all of the data related to any sampling done in this portal, and you can download and export all this data as well. So some programs and data that you might find in this portal are CSLAP, or Citizen Statewide Lake Assessment Program data, and WAVE, or Water Assessment by Volunteer Evaluators data. These are both citizen science programs that utilize volunteers to collect valuable data in their areas that can use for later analyses. And then specifically for DEC, we have a couple programs. We have the Lakes program, or LCI, the Lake Classification and Inventory Program, which has more than 7,600 bodies of water that are evaluated through a 5-year rotating basin. And we also have a streams program, which was initiated in 1972 and focuses on the screening network and special survey monitoring strategies for approximately 75 river and stream locations across the state, with some additional locations being sampled periodically throughout the year. For the Finger Lakes program specifically, we are participating in a special study. We started this past summer, and we're going to continue it again this year. So we have sampled all of the Finger Lakes once a month for 4 months last year, and we'll do 4 months again this year. And we are going to use this data to hopefully result in a report with the data being available once it's completed. There are also lots of local monitoring programs that are conducted by nonprofit organizations or private organizations, and of course, academic researchers as well. But the most relevant for this talk is the NIHABS program, which I'm sure this crowd is probably no stranger to. So the New York Harmful Algal Blooms program is a citizen reporting tool that allows people to submit suspicious bloom reports across the state. Over 650 water bodies have reported harmful algal blooms, with an average of 200 water bodies having a HAB each year. So to continue on the line of research, I would like to speak on a piece of research completed by the state that uses the harmful algal blooms analytical data, beach closures, and public reporting from 2012 through 2020. This work by Rebecca Gorney and the team analyzed 24,000 records on 655 water bodies for the frequency of reports of HABs across New York State, the intensity, and the duration, looking at the average length of beach closures. They found that half of the lakes tested had only 1 year in which a HAB was documented, and less than 1%, or 6 lakes of the lakes that were analyzed, had a HAB documented every year of the study, which is shown in the bar chart below. For intensity, there was a significant increase in the number of harmful algal bloom reports each year, but not an overall increase in intensity based on the evaluation of chlorophyll levels in lake samples collected routinely. The increase in the number of HABs reports can be attributed to a larger awareness or more people reporting. So this is what we call observer bias. So the more we have people looking, the more reports we are expected to see. And for duration, we found that it did not lengthen over the study period based on beach closure data captured. And the figure to the right shows the season length or time between the first and last confirmed harmful algal bloom over the last 10 years in the Southeast Lake Ontario subbasin, which includes the Finger Lakes. We generally don't see a change in the length of season over the last 10 years, although the number of reports has increased, again, supporting that the number of reports could be attributed to observer bias. Another piece of work is currently under review and is striving to alleviate this observer bias through the use of satellite imagery to provide a more broad and unbiased observation of HAB occurrence statewide by using the satellite Sentinel-2, which offers a 5-day flyover at high 10-meter resolution, allowing for the application to relatively small lakes across the state, much like the Finger Lakes. This takes away the observer bias introduced through targeted monitoring, such as what we have with the NIHABS program, where we often receive multiple reports on the same day of the same HAB. So we use Google Earth Engine and are able to estimate concentrations of phycocyanin, which is a blue-green pigment found in certain microalgae and cyanobacteria. So here is an example of what the application of that method on Seneca Lake looks like in 2024. So on the left, we have the poll from NIHABS showing the confirmed reports and an image of one of those reports. And then in the middle, we have a satellite image of the northern end of Seneca Lake showing a pretty widespread harmful algal bloom and an image taken by plane of the event as well. And then on the right, we have the outputs of the satellite work, which shows the estimated concentrations of phycocyanin in micrograms per liter. And we hope that this work could serve as a way to reduce bias and evaluate HABs before and after implementation of management actions that may be included in clean water plans, which I will speak on next. So for clean water planning, all 11 of the Finger Lakes have completed a division of water recognized plan, with some being included in 9-element plans, total maximum daily loads or TMDLs, drinking water source protection plans or DWISPs, and HABs action plans. I also want to note that those in red have been completed since 2018, so there has been significant progress completed within the Finger Lakes over the last several years in terms of clean water planning. And you may be wondering, why is phosphorus the focus of these plans? So as I mentioned before, phosphorus is specifically called out as it is now the only factor we do have some control over. But phosphorus is also often the nutrient that limits algal or phytoplankton growth in freshwater ecosystems. So a nitrogen to phosphorus ratio of greater than 20 indicates a phosphorus limitation. And to put this into perspective, the ratio of nitrogen and phosphorus for Seneca is about 70-1. Phosphorus also correlates with chlorophyll and cyanobacteria. In the image on the left, this is from a study on the experimental lakes in Canada. So on the top of the picture, there is a portion of the lake where phosphorus was not added. And on the bottom, there is a section of the lake where phosphorus was added. So where the phosphorus was added, there were harmful algal blooms, but not in the section where it was not in excess. And the figure on the right shows a high R² value, which tests the relationship with chlorophyll A and phosphorus. And to finish up this section, there has been a significant amount of funding awarded for specifically nutrient reduction projects, with about $530 million to this date, and 14 million of that awarded for HABs research. We acknowledge and understand that clean water plans require progress tracking of some kind in order to measure success. And the DEC is currently working on a project tracking system that can be used to track watershed progress, locate gaps, and visualize progress. This shows the investment summary, load reductions, and project information. The table shows the funding sources that are currently included in this tracker, and the map shows where funding has been allocated in the Seneca watershed over the history of the programs listed in the table. So to date, for all of the databases included in the project tracker, over $9 million has been awarded in the Seneca watershed and over 38 projects. Okay, so now that we have gone over some of the work that has been completed, I'd like to spend a few minutes discussing what comes next. So for general research, I encourage researchers to use the New York State DEC HABS Research Guide, which was published in 2021 to help guide paths forward for research. I won't go over this entire list in detail, but I just want to highlight that the lines highlighted in green are completed or are currently underway. And I want to specifically mention that we are all aware that HABs are a very complex issue, and it is important to collaborate with partners in New York State and other states in order to learn from one another. So we are therefore participating in the Great Lakes HABs Collaborative, which provides an opportunity to work with researchers investing and investigating in harmful algal blooms in the Great Lakes states to support and learn from one another. And then for mitigation, there are many pieces of work that have been completed to investigate in water body mitigation, but the results have been mixed. It is outside the scope of my presentation today to go into each of these in detail, but I encourage you to check out the DEC HABs website to learn more. But to summarize, I don't want to sugarcoat it. There really is a lack of results for these mitigation efforts, and it is really on a lake by lake basis how well these can work. So in-lake mitigation is really a short-term solution, but it is valuable to preserve the recreational use of the lake. Long-term watershed planning is what is really necessary for a long-term solution. So with that, I am going to turn it back over to Emily. I want to thank you again for having me, and my information's on the slide if you want to reach out. Thank you.
Okay, thanks, Lexie. And as I said, we have one more presenter, and then we will have lots of time for questions. Okay, so last up, we have Rick Smith and Stella Woodard. Rick is actually going to present, and then Rick and Stella are going to be available on the panel. And they are going to talk about Finger Lakes, harmful algal blooms, foam, and PFAS transport, and how it is all connected. Okay, there are a lot of big words in these bios, so stick with me, everyone. Okay. Rick is a chemical oceanographer and founder of Global Aquatic Research, a consulting firm focused on marine and freshwater chemistry. He holds a PhD from Texas A&M and has led research around the globe on wetlands, lakes, and coastal ecosystems or systems. Over the past 5 years, his work has centered on water quality issues in the Finger Lakes, lucky us, with a focus on harmful algal blooms and pollutant dynamics in natural waters. Stella Woodard holds a PhD in geological oceanography from Texas A&M. Following a postdoc at Rutgers studying deep ocean currents and climate, she co-founded Global Aquatic Research, where she spent the past decade as a scientific consultant. Stella specializes in trace metals, sediment geochemistry, and climate reconstructions, and has led major projects like the Tempest Ecosystem Experiment at the Smithsonian Environmental Research Center, the largest ecosystem manipulation experiment of its kind. Tempest creates floods in a coastal ecosystem on demand, allowing teams of researchers to study soil and forest impacts. Let me tell you, I went down a rabbit hole when I Googled that. It is really cool. So maybe we'll have Stella talk about that another time, because that's also a really amazing project. Most recently, she's focused on water quality issues in New York as well, with ongoing work in several Finger Lakes. And this evening, they are going to talk to us about recently found evidence that biopolymer production during cyanobacterial harmful algal blooms drives the formation of surface foam in the Finger Lakes. Foam can scavenge legacy and emerging pollutants in lakes, and Rick will discuss the role that HABs and foam formation may play in the cycling and fate of per and polyfluoroalkyl substances, also known as PFAS, in Seneca Lake, key knowledge gaps, and next steps. And I know that was a mouthful, but I've heard them speak, and it's so amazing because they're gonna speak in a way that we can all understand. So, let me take it away. Oh, look at that. There we go. Rick? Yeah. And then
Can everybody?
that one we can move around.
Yeah, that'll be great.
Just forward, backward.
Okay, awesome. Well, thank you so much, Emily. Really appreciate it. And thanks for having us here today. I'm always very inspired when I come here and talk with everybody, because the work that we do couldn't be made possible without the huge commitment that we have from citizens, volunteers, lake associations, people doing stuff on the ground like what Ian talked about, and of course all the work that the DEC has done to monitor the huge amount of streams, lakes, and ponds around New York. So our piece of this is, I started global aquatic research a little over 10 years ago when I left my postdoc working for the University of Connecticut Department of Marine Science. And what we really are scientific consultants. So we try to take leading research, technology, and try to apply it to real world problems. So we're kind of the linkage between academic settings and organizations on the ground. Over the last 5 years, we've been doing a lot of work in the Finger Lakes, and that's really what I'm going to focus on today. So I want to talk about foam, and most of that research thus far has been done on Canandaigua Lake, a little bit on Skinny Atlas, and now we have a grant this summer that I'm going to talk about to also work on Seneca, which is huge for me. Even though I grew up near Rochester, my grandparents lived right across the street from Hobart William Smith, the White Springs farm my other grandparents grew up on, so I have a long family connection to this area. And I want to talk about PFAS in foam, which is what we're going to be working on in Seneca later this summer, and then think about next steps and discussion, and some of that we might end up doing on the panel. So I'm going to try to keep this high level and not get too much in the weeds. We started working on Canandaigua Lake when we were sent this photo from Lindsay McMillan of the Canandaigua Lake Watershed Association. And in all my years of doing oceanography and lake science, I'd never actually seen anything quite like this. This is a huge amount of surface foam accumulation. And the question that Lindsay asked us was, what is this stuff? So my background is in looking at natural organic matter and characterizing it, especially when there's complex mixtures. So it was a really good fit for our business and the work that we do. So we thought, well, we're only going from this one photo, so why don't we create a foam reporting tool? And with that tool, we can distribute it to volunteers along the lake, and they can submit their own reports. They come right to our phones, mine and Stella's, so we have eyes on the lakes all the time. And I'm going to talk about this tool later because we're going to be expanding it to Seneca this year. So what we've seen with now the hundreds of photos of foam that we have through this tool, and also through the observations that we've made when we're out on the lakes, we'll be out there all summer, is that foam typically starts with these Langmuir circulation cells. So when the wind blows out of the south, you get water mixing and you get these basically lines of foam bubbles. Now, in a normal conditions, these bubbles are not very stable and they break. But in the Finger Lakes, what's going on is they are very stable and they converge and you get these really large mid-lake streaks. These streaks then blow along shore, and then you get these big shaving cream-like accumulations that can persist for days. And in the world of foam, that is incredibly stable. Even things that persist for hours are considered very stable. Okay, so what have we found about this? Now I'm going to skip over all the really detailed data. We have some on a poster over here, and you can Google our foam report that we've done for Canandaigua. It's on a couple places on the web if you really want to get into the technical stuff. But we've pieced together through that initial Canandaigua Lake study and through several studies that we've done afterwards, we've basically pieced together a body of evidence that shows that this foam is very enriched in polysaccharides. What polysaccharides are long chains of sugars. They're a type of biologically produced polymer. And where we think these are coming from are from these microcystis communities that Lexie talked about. So this is actually a microscopic image from USGS, and each of these little brown circles is a microcystis cell. So they clump together in colonies. But this kind of see-through material at the edges, that are what's called exopolymeric substances. Those are very polysaccharide rich. And the reason that these cells produce this is to help their colonies clump together. They can regulate their environment, and they even use them to farm different types of bacteria that live symbiotically with them. So they produce a lot of this stuff. And in lakes in China, where they've been doing a lot of microcystis research for years because they have very eutrophic lakes, when these things bloom, they can drastically change the chemistry of the lake. And what we're seeing with our foam reporting tool is seasonality of reports. And we can see this is exactly what Lexie showed with this succession of different types of phytoplankton throughout the year. And what we can see is that our foam reports typically come in late summer and in the fall, and they coincide pretty well with when blue-greens bloom slightly later, because we think these polysaccharides need to degrade a couple of weeks to create the perfect conditions. So usually when we start to see big halves, typically we start seeing foam about 2 weeks later. This stuff is a nightmare to work with. I've never worked with a natural sample quite like this foam. This is actually a hair gel-like substance that we got when we tried to do fatty acid extractions in the lab. And once this stuff forms, you can only redissolve it in boiling methanol, and it clogs instruments. And so it's taken us years to work with partners and figure out people who, can take on the risk of working with this stuff. And we've really developed quite a number of techniques. So it's become a pretty big body of work for us. And as like I said, I don't want to get too much into the technical details, but I do at least want to show a figure or two. So this is from our partners in Scotland at the Heriot-Watt University, the Lyell Center, which is like the USGS of the UK. And they happen to have a piece of equipment that there's only about 5 of them in the whole world. And this is huge because when we want to look at several different types of naturally occurring organic matter in the lab, we typically have to do different methods for each of them. They're very costly. But what this technique, called LC-OCD-OND for short, allows you to do is inject one water sample. It goes through a series of different columns and a series of different types of detectors, and we can get a huge amount of information from one water sample injection. What we see at the top, each one of those peaks is a different type of naturally occurring organic matter. And at the top, that's a Canandaigua lake water sample, and that big peak is humic substances. So that's stuff that runs off from soils and comes down streams into the lake, and it can even come from wastewater. So that's pretty typical. That's what we would expect. But take a look at the foam sample. The foam sample has one large peak, and that's a biopolymer peak. So that kind of just shows the enrichment of these biopolymers, these polysaccharides that are entering the foam from lake water. Well, is that actually causing the water to foam? So we need to correlate that with something that actually looks at, say, the physical nature of the water, and that's surfactant activity. So when you think about foam are air bubbles surrounded by a thin film of water. And if that water has very high surface tension, the hydrogen bonds in that water make that bubble pop. But if you have very low surface tension, you surround that air bubble with an even film of water, and it's very, very stable. So as the amount of surfactants go up, the surface of tension of the water reduces, and it increases the chances that the water is going to foam. So what we see here are great correlations between surfactant activity, or the ability of the water to foam, with the amount of organic matter in the water. So as organic matter goes up, there's more likely going to be foam. We see this relationship with the biopolymers and also with the humic substances, although the humic substances are not as enriched in the foam as the biopolymers. So the biopolymers kind of have, in the data, they always fall out as driving this activity. One thing that's interesting is that the amount of proteins in the foam, actually those have the opposite trend. And that was interesting because one of our initial hypotheses when we thought about this, we said, well, what's going on? We're seeing a lot of foam. We're getting HABs. We also have invasive mussels. And some folks thought it might be invasive mussel die-off. Well, we don't think that's the case because the proteins really do not correlate with this changing physical nature of the water to create foaming. So it does seem to be coming from these HABs. And I think this picture really drives home everything that we're seeing here. So this was out on the lake a couple of years ago, and we were on Canandaigua. We were actually trying to sample foam. And this is a giant patch of a microcystis bloom. And so you can see the green dots in the water, you can see the streaks. And what you can see at the edge of this photo is kind of a line. And this is all very smooth water, what we call a surface slick. And past this line is just kind of normal, little bit roughish water. So this surface slick, that's the accumulation of organic material that these algae blooms are releasing. And when they release them, the ones that are not very soluble in water rise right to the top. And that's called the surface microlayer. That's the top 1 millimeter of water. That chemistry of that surface microlayer is what is allowing foam to form. And we can see that not only do we have the HAB, not only do we have the surface slick from all the stuff that they're releasing, but we're actually getting fresh foam to form right above the harmful algae bloom. So why do we care about foam? Other than the fact that people might drive by it, not know what it is, and say, you know, that looks kind of disgusting, especially when it's been cooking on shore for a little bit. Well, we care about it because foam actually provides chemically something that's different from water. So things that are not very water soluble will end up in foam as opposed to in lake water. So foam can actually scavenge things from the water. And some of these things are contaminants. So if you think about a contaminant like PCBs, they're not very soluble in water. They sorb the particulates, they enter sediments. And so one of the things that we do is we say, well, if we don't disturb the sediments, PCBs will accumulate and they'll eventually be buried. But if we have mussels, especially quagga mussels, disturbing sediments, we get organic matter breakdown, bubbles can scavenge that stuff up and bring it to the top. And those things can end up in things like this. Now, there's research from other areas that have shown elevated concentrations of heavy metals, PCBs, and things in different systems that have gotten foam. We have to do a lot of this research still in the Finger Lakes. And of course, why we care about that is once foam forms, it typically blows to the downwind shorelines. So this is from Seneca Lake on the northeast side at the state park. We can see the fresh foam kind of blowing in here, and we can see all this really dried foam right here, this pretty large patch. And then once it dries, it kind of blows along the shore and creates all these dried patches. So if you think over the summer and fall, it's the same areas that are constantly getting this foam blowing along shore. So looking at studies that have been done showing that this foam can scavenge contaminants from the lake, it means we really need to understand what's going on in the Finger Lakes, because should we be cleaning this stuff up? Or are there ways to prevent its formation? So, okay, so we have done a little bit of this work in the Finger Lakes in terms of looking at toxins and contaminants, and I'm going to talk about that really quick and try to relate it to the chemistry of these compounds. So these are microcystins. This is what the microcystis algae that Lexie was talking about are producing. Here's the toxin right here. And what we did is in 2 different research projects in 2019 and 2022, we measured these in foam samples, both in the middle of the lake. Here's a giant patch of foam covering a huge portion of the southern end of Canandaigua Lake. And that was one of the samples we took. And also shoreline samples. The blue is lake water. So when we take a foam sample, we take a sample of lake water right next to the foam patch to compare them. So the blue is lake water, the yellow is foam, and what we can see is microcystins are almost always higher in foam compared to lake water. But it's kind of unpredictable. If you take a look at this sample right here, lake water microcystins were barely above the detection limit, and the microcystins in the foam were, over 16, so over 4 times the limit at which they close beaches. But if you actually look at these bars, we have the dark yellow and we have the light yellow. And the dark yellow is actually microcystins that are bound in algal cells. So they make these things, but they don't always release them into the water. And they'll be what's called intracellular microcystins. And the light yellow is ones that have been released into the water. So what we found is that most of these microcystins that are in the foam are actually still in cells. And that makes a lot of sense because microcystins are very soluble in water. So that process that I was talking about foam scavenging based on the chemical structure, is not happening with microcystins. What we think is happening is that the foam just picks up everything that's in the lake as it's blowing to shore. And because it's produced during the same season, it's just picking up a lot of algal cells. But that's not the case with all contaminants, as I mentioned. So the other one we looked at is per and polyfluoroalkyl substances. So these compounds have been around for a few decades. They're called forever chemicals because for the most part, they never break down. And that's also what made them good for industrial applications, right? You don't want to have to constantly change fluids and things like that. They have properties where they repel both oil and water. So they are like super surfactants. And because of that, they're the exact type of thing that we would expect to become enriched in the surface microlayer and be found in things like foam. And other studies like in lakes in Michigan have shown enrichment in foam. So we got funding from Freshwater Future and we worked with Canandaigua Lake Watershed Association. And what we found is that in Canandaigua Lake, PFAS are about 5 parts per trillion in lake water, which is, relatively speaking, pretty low in parts per trillion, nanograms per liter. But what we can see in foam is that they're consistently enriched about 70 times. So in our foam samples, we found almost 400 parts per trillion. And what was really interesting is that these foam samples were very different. So we have kind of this aging foam, blown up against these docks. We have this very thin film of foam up by the boathouses. And then we also got some foam streaks, and they were all pretty similar in terms of their PFAS enrichment. That is evidence that this is a very chemical solubility-based process. And what's interesting is that we're finding the same compounds in each foam sample, and it's very different than what we're finding in lake water. So the foam is enriching certain types of PFAS, and one of these is PFOS, which is one of the handful of PFAS that are actually regulated in drinking water, and we found none in the lake water. So that would be a success. If you measured the lake water, you wouldn't find it. But you're not looking for it in the right spot. It's very enriched in the foam. So these are all things, there was kind of some more that I wanted to talk about chemically and why these PFAS are found, but I think I'm going to have to save that for another talk. But the point is that we are seeing that foam is scavenging contaminants. We need to get a broader view of what foam is scavenging. We need to think about, should it be cleaned up? I just wanted to really quickly, Emily, do I have to end? Okay, I'll go quick though. So taking the PFAS report from Seneca Lake, how does our data from Canandaigua Lake compare? So this is from the work that Cornell did in collaboration with FLI, and I took the data, put it into put our Canandaigua Lake data, ours is a software program, or like a data analysis program. But what we found is that, so over here's Seneca, over here's Canandaigua Lake, and then from Seneca, I took the lake water data, in the data from the tributaries that are draining the Army Depot, which had the highest hits. And then I took our Canandaigua Lake water in foam. And for each one of these, on the left in red is total PFAS, and on the right in yellow is PFOS. In lake water, in Seneca and Canandaigua, total PFAS is pretty low. In a few parts per trillion, PFOS was not detected in either. In the depot tributaries, we have more elevated concentrations of PFAS. Okay, so somewhere, 25 to 50 parts per trillion, kind of a broader range. If you look at all the samples, there are only 3 tributaries, and they did find some PFOS. But if you look at the Canandaigua Lake foam, total PFAS are way up here. And this is an axis break. So they're up closer to 400. And we also had very elevated concentrations of PFOS. So some of this, if you look at total PFAS, it's hard to compare apples to apples. Cornell was looking at 17 compounds. We looked at 30 in Canandaigua, and our newer methods looking at 40. So part of it has to do with how many you're adding up. But PFOS is PFOS. That's the same measurement. And what we're seeing is that as a regulated PFAS, it's almost uniquely found in foam. So this summer, we're going to be working on a WRI project. We're going to be expanding our PFAS testing to Seneca and a few other lakes, Keuka, Wasco, Skinny Atlas. And we're going to be looking at not only the surface water and foam, but the surface microlayer. So we're going to try to get a signature of the water before that foam forms. And we do that with a sampling instrument called a Garrett screen that just kind of kisses the surface of the water and just takes off that thin film. And we're going to be expanding that foam reporting tool that I talked about to these other lakes. So if you get a chance, come over to our booth. You can sign up to be a volunteer on the foam reporting tool. You don't have to sign up to be a member of it. We're going to work with the lake associations and make sure everyone has access to this tool. You can take a look at Canandaigua Lake Association's website here to see what this tool is all about, but don't submit any reports yet if you're not part of Canandaigua Lake, or if you're not seeing foam on Canandaigua Lake, because we're going to be actually taking this and making it applicable to all the lakes over the next couple of weeks. And then we're going to be asking that in the fall, actually summer and fall, that when people see foam to report it using these links, and therefore we can make sure we show up at the right time to sample it. And we can also start to visually see, is this all the same on the other lakes as we're seeing on Canandaigua? So it'll be great to get people's input. With that, I think I'm probably over time. So just some of the big questions that we're looking at: what other contaminants do we need to monitor? Should foam be cleaned up? And how comparable is our data in Canandaigua to other lakes? And then farther than that, we're really interested in what's driving HABs in low nutrient lakes. So some of these things that Lexie was talking about, can we identify manageable drivers? If phosphorus is the only thing right now we're looking at, we need to think there's actually several different forms of phosphorus. Should we be looking at nitrogen, and what's the role of organic matter? If you look at studies from the oceanographic world, organic matter can sustain cyanobacterial blooms in low phosphorus systems. So there's a lot of work to be done. I know I went over some of that at the end relatively quickly, but just know that our business is here to help with some of these things. This is what we do. Please reach out to us at any time, and I'll leave all questions up to the panel after that. So thank you.
Okay, awesome. Thanks, Rick. So yes, we received a lot of reports of foam late in the summer and the fall into November on Seneca Lake, and we were getting lots of photos from people and locations. So we're really excited that we're going to be a part of this new research happening and using the foam reporting tool. Again, not to harp on the new website, but we do have a page right on the website about foam. And so we're going to have it, linked there when it's ready for our lake to start using it, and all the information and resources about it. So that is all coming. Alrighty. So if everybody that was a presenter wants to step right up. Dun, dun, dun. Okay. So, as promised, we have plenty of time for questions. So I have Bill and I have Tim. They're going to spread out so that if you want to ask a question, you can be heard. And then you can fire away to whoever you would like. To share that microphone and pass it back and forth.
Here. Hi, Rick Stu. Question about the PFAS. If you're seeing elevated levels in the foam and the foam blowing up on the shore, have you guys thought about the sediments along the shoreline where humans are more prone to be exposed, and how the sediment concentrations along the shore might compare with offshore, to just be another piece to the puzzle? Has anyone done anything like that, or is that of consideration?
that's the next phase of research that we're hoping to do. And that was one reason why I wanted to show that picture from Seneca Lake, because you could clearly see that this stuff does dry and does blow around onto shore and impact, the coast. So that is what I see as one of the next phases of research to do, is to look at those concentrations.
Is it safe to swim and eat fish from Seneca Lake now? Is it safer than it was, or is it worse?
Let's say you're the DEC rep that has advisory. It's something.
I think that question, I guess, is for me. I would defer to any fish related regulations to our fisheries department. I know that there is a layer on the DEC info locator layer that includes the fish advisories on a watershed basis. So I would encourage you to look there. And as far as I know, the water quality in Seneca Lake has held pretty consistent. Like I mentioned, we're doing the LCI sampling. We did it last year and we're doing it again this year, and we'll have the results of that soon.
There's a question here.
Is the foam toxic?
Well, I mean, I guess it depends kind of on the definition of toxic. And really, if you look at, the one thing that I can't speak to is necessarily health exposure studies. That's like a different field of research that I'm in. So I'm really just looking at these compounds in terms of their fate, transport, cycling, and concentrations. So I guess, is that a question for you, Lexie? Or is that something, I think that that's all research that still has to be done. This is all very field.
And I would just add that if you see large amounts of it, don't swim through it or wash yourself very well if you come into contact with it. It's just common sense, I guess, from what we found, but there's so much that's unknown that, I would hate for people to be afraid to swim in the lake, but certainly if there's a huge patch of foam, you probably don't want to swim through that.
When that breaks down on the beach, is those compounds remain volatile, and are they like sediments into the beach, or do they break down and become something different?
That's still stuff we all have to understand too. And that's just how young this part of research is, in the sense that, the foam's only been around for a few years. We're still understanding what it is. We're now looking at other compounds that could be in it, and the
compounds do not break down, but whether they remain where you'll come into contact with them or they move down into the, near where the groundwater is or into the sediment and they're stored there, that, but PFAS themselves are incredibly stable. That's why they're starting to regulate them, because they're just going to be around forever.
And, and one thing is, like I said, these are parts per trillion concentrations. So what does that mean? They've shown that these can have health effects at relatively low levels. So they definitely need to be looked into, even at these concentrations. The Department of Health, when we asked them this question about should foam be avoided, they said, well, if you can't see the bottom, if you can't see the lake bottom, don't swim. That's basically their general rule, because that applies to HABs, that applies to foam. So that's kind of what we've gotten for now. I think we just need to keep pushing this research forward. And yeah, so.
We have a question from online.
Yes, from an online contestant. Is there coordination taking place with the PFAS research and mitigation work being done by the Army Depot engineers? That's a heavy question, I think.
Not with us. With our research right now, it's been entirely separate.
There's been some discussion about the increased heating of the water from Dresden, where the Bitcoin manufacturing is going on, and how is that impacting the heat and the HABs?
I have like an irrational fear of microphones, so this is like kind of scary for me. So the water temperatures, yes, water temperature is related to increased harmful algal blooms. So with the warmer temperatures, there can be an increase, but there are so many other factors that contribute as well. I know it's really important for specifically streams to have riparian buffers that are able to cool the streams down before the water is entering the lake to hopefully mitigate the harmful algal blooms that way too.
Yes, thank you. I have an answer. This gentleman asked if it's safe to eat the fish or not. Last year at this time, at the Lake Trout Derby, Fingerlinks Institute was taking samples of the lake trout. And I believe there's data how much PFAS and PFABs were in the lake trout. And do you know what that statistic was, Ian? I thought it was acceptable.
Well, correct me if I'm wrong, but there's a drinking water standard for PFAS and PFOS, but there isn't a consumption standard for like associated with fish consumption and levels of PFAS. So.
Okay, for Lexie, Jake Welch, Seneca Pure Waters. So I know you talked a lot about cyanobacteria, phosphates, and Rick hit upon this at the very end of his discussion where he talked about some of the lakes that have low phosphates like Skinny Atlas, Canandaigua, and how even when they're still having harmful algal blooms. I'm just wondering, so the concern is we do all this huge amount of work to reduce phosphates. Does the DEC have sort of a backup plan for we do all that phosphate reduction and then we still find out, like on these other lakes, we're still having cyanobacteria problems because cyanobacteria are very good at adapting and might be able to survive on nitrogen or organic materials. Is the DEC saying, well, if that happens, what are we going to do?
So I'm not going to speak on an official DEC capacity on this. But like I mentioned, there are lots of other factors that contribute to harmful algal blooms. So the presence of dry-scented mussels, for example, the lake fetch and lake orientation. So unfortunately for the Finger Lakes, they check off all of the boxes. We are encouraged to encourage other researchers to look at those other sources and also to consider that we are doing our best with implementation efforts to reduce nutrients into the lakes. So if those were to stop, to maybe imagine what happened to the nutrient levels within the lake.
As part of a solution to the foam issue, and the foams concentrate many of the undesirable things, would it be even feasible, as part of a solution to have a device that basically sucks up the foam while it is in the lake before it gets to shore? Would that even be feasible?
Well, it's something we've been thinking about and looking into. And, kind of the logistics that would be required, would this be something that would be out in the middle of the lake? And would we have, some device kind of, trailing from the back of a boat, like you would clean up an oil spill and kind of collect all this? And then would you run it through a vacuum? And would it just be a matter of breaking up the foam and returning it to the lake and saying, well, you're not going to change the concentrations of this stuff in the lake, even by taking foam up, because the lake has so much water in it. So if you think about concentrations of stuff, And that's, numbers that we still have to do because we don't really even know kind of what's in the foam. These are very preliminary, thinking about concentrations and absolute masses of stuff. So would you just break it up and return to the lake? And is it a matter of just preventing it from blowing to shore and impacting, downwind shorelines? Or do we want to send it off to be treated? So I think these are really collaborative discussions that we have to have with some more background research and maybe get a couple of prototypes off the ground of like some collection systems. So yeah, those are all the things that we're thinking of, but it's very difficult too, because this foam, if you try to run foam through a filter, like a cartridge that would capture, say, certain types of contaminants, the foam will just clog it right up. So these are some of the challenges that we're dealing with. How to break it down? Do we clean it? What happens with it, with the byproducts? So yeah, I think we need some pilot projects.
This is a question for Lexie. Lexie, we've grown on Seneca Lake from 20 HABs monitors to 40 to 120. Obviously, you have more monitors, you're going to find more HABs. So this issue of observation bias comes up. In the long run, how are we going to take that out of our data so that we know Seneca Lake is getting worse or getting better? Is it really satellite monitoring in the end that may help with that? I'm really curious what you think.
That's a really good question. And I do want to say that Seneca Lake has a crazy amount of volunteers that are out there. So I am really impressed with the volunteer program that you have for monitoring HABs. And I think it's really something to be proud of. With that, like you mentioned, the observer bias comes with that. We are always thinking of ways that we can eliminate that observer bias. And the one way that we're looking into right now is that satellite observation or remote sensing. So I know in the Great Lakes for Lake Erie, for example, they do this, and they also have been able to use their satellite imagery to also do HABs forecasting. So kind of predicting the HABs season of sorts. So hopefully that satellite work will be published soon, and you can read more about it then.
That answers part of my question, and which is, are we alone in this wilderness? In other words, there's lots of lakes that are very big. We're unique in that we have a lot of them all together. Does that make us a unique place where this happens, or are this kind of research ongoing at other places, and are things being found that really has become helpful for us?
That's a really good question. So like I mentioned, we are a part of the HABs Collaborative, which is a collaborative effort with all of the Great Lakes states to come together and talk about harmful algal bloom research and all the things related to that. I think the Finger Lakes region is unique for a lot of reasons, but one of those being that all of the lakes are so close together. But I think it's really important to understand and to think about how different the watersheds of each of the individual Finger Lakes are themselves, and what we should be thinking about in terms of HABs mitigation in relation to the specific lake watershed challenges.
And I would just add to that this is a problem all over the world. As the climate is getting warmer, there are a lot of areas in Europe that, especially in Italy, up in the Alps, where they have these lakes that are actually kind of similar to ours, but larger. They're seeing harmful algal blooms that they just didn't see in Switzerland and Italy. And it's probably because the lakes are not freezing the same way that they used to. They're not mixing the same way, and the overall water temperature is slightly warmer.
Is there any research being done that you know of, which is about killing the blue algae and all these other biological things? That wouldn't take care of the metallic aspect of the pollution, but that might be a safer thing.
These organisms have been around for billions of years. we can kill them on a small scale, maybe. That's what some of the bubbling technology, people are trying to lyse the cells, use hydrogen peroxide, those type of things. But the idea that we're going to eliminate this cyanobacteria is just not going to happen. They have had billions of years to adapt and develop, you know, all kinds of strategies to survive, and they're really good at it. So I think, you know, thinking about how we can kind of be better stewards to our watershed and the lakes to reduce the likelihood of blooms is something. But, you know, when I tell people about microcystis or about cyanobacteria, I say they're very cosmopolitan. They're found everywhere in the world in freshwater systems. And it's just when the conditions get right that they go crazy, and then we have problems. So.
And yeah, I'll add the fact that, you know, you're talking about a microorganism, right? And they have reproductive rates that can be measured in seconds and minutes. So the theoretical, even if you could eliminate it from the entire food web, I mean, it seems implausible. And they were there, as you said, they've been around millions of years. They've been there all along, just not at the levels that we've seen, right? And now, since I'm not with the DEC, I can speculate a little bit. I mean, what we really need in my opinion, from a miracle, to some degree, is find a control for the mussels. I mean, Lexie mentioned that one of the strongest indicators, along with phosphorus, is the presence of Dracaena mussels. I don't think it's, you know, a coincidence that we didn't see HABs on all the Finger Lakes until 2017, and it correlates pretty closely with the presence of Dracaena mussels in the watershed, the whole Finger Lakes watershed. So that link seems inherent. We got fortunate historically with USGS happened to find a control for sea lamprey in the Great Lakes. So maybe we can get lucky again. Who knows?
Most of us get our water from the lake, at least a lot of us do. How deep in the water column do the toxins go?
That's a great question. And I don't have an answer to that, but I can say some of the considerations. And I know, you know, some of the work that the DEC has been doing, like Tony Prestigiacomo, he had a paper in Canandaigua moving off of the north end, and he was kind of looking at downcore water profile distributions of microcystis. But there's a lot going on. One is that the depth of the thermocline changes throughout the year. And so we really need to think about where in the water column these things are. And the thermocline could be the lower bound for them, but of course that's going to change. But these things can also sink. They can regulate their ballast. So they can actually be up in the surface getting sunlight during the day. And at night, they've been known to sink down and get sources of phosphorus from the sediments. Now, is this really happening in the Finger Lakes? We don't quite know. They're very deep. So are they really going to sink that entire distance and come back up? I don't know. But in other lakes that they've studied these things, they'll actually sink to the bottom and overwinter and then be reseeded in the spring. And we really know nothing about that in the Finger Lakes as well. Are they doing that? Where are these seed banks? Can they be mitigated while they're in the sediments overwintering? And I don't know the answer to that. So I guess it's kind of a long-winded answer to your question, but I just kind of want to point out to how complex these things are. Maybe there's a simple answer to how deep a water intake should go, though, as deep as possible.
Yeah, so we are maybe not looking into some of those things right now. And we'll hopefully have some results that we'll be able to share in the next maybe years or so.
I will say that off the top of my head, 3 water purveyors in the Seneca Lake have all detected microcystin in the raw water intake, never in the finished water. So the treatment systems are working, and that is why the village of Waterloo invested heavily in a granular activated filter that just came on this year, as a safety measure against that concern. And the operators try to operate in such a way as to limit exposure to, you know, that those compounds getting into the raw water intake as an extra precaution, but it has been detected.
And I'll just add as well, for people not on the public water supply, traditional filter systems that you might have had aren't necessarily set up to work, or, you know, they don't necessarily work for microcystis and PFAS and things like that. But there is some information about, you know, more advanced treatment options like activated carbon and things like that, that are possible for homeowners to install. And we have it on our website. I don't have it with me, but you could always just reach out to us and we can give you that information as well if you're in that situation of a private water intake and looking for some more details.
And on a plus, it works for PFAS too.
Yeah.
So I'm taking water out of the lake for household purposes, dishes and showers and toilet and things like that. And I've got a 5-micron filter on it. That's not going to save me. So we shouldn't draw water then when we have a HABs outbreak on the shore. Okay, thank you.
Well, I can yell this out. Again, Lexie, if we have an intense HABs outbreak on the lake, and these toxins actually bubble up into the air. I asked that because we had an intense outbreak. I was driving in the boat and I saw people on their dock with masks on, happened to be friends. And I said, why are you doing that? He said, because we're worried that this could actually bubble up. And I've read some articles that suggest that. I don't know that people even think about that, but is it possible?
I have heard of some studies that have looked at this, like aeration. I don't know of any happening around here. I don't know if you wanted to speak to that a little bit more.
So there are people in Massachusetts that have looked at whether, you know, these cells can get lifted into the air and then do some toxicity studies. Unfortunately, I can't tell you all the details about that because I just can't remember them off the top of my head. I will say that I have been out on the lake in the middle of very active blooms, and it's probably, I don't know what my exposure to microcystins was, but I had a raw throat at the end of the day. And so certainly if you're sensitive, you know, that stuff is getting into the air, especially if you're right on top of a bloom for several hours like I was.
Yeah.
Sorry.
Oh, yeah, we decided after a couple of days of sitting over HABs for several hours working on them that we're going to start wearing masks on the boat. But like I said, that's just kind of precautionary for us. That's not necessarily saying, and there are other things that algae blooms produce too. So like Stella said, that's not necessarily a microcystin toxin, but, and it could have been that we just both happened to have colds the 2 times that we went out and that happened. But so, yeah, I think that what needs to happen is we really need to get together these different pieces of HABs research, looking at all these exposures, and there needs to be some kind of broad review about how these apply to the Finger Lakes and get some more discrete answers to these questions. Because one thing that I can tell from these conversations is that there's a lot we still need to know. And part of that is just due to how new this problem is and how quick it's been ramping up, and the fact that there is limited amounts of funding to try to understand some of this stuff. So.
Well, I bring that up because one day I spent a full day painting the perimeter board of my dock, and a few days later I caught pneumonia. So I consulted with my wife, and she says, "Don't ever do that again." Yeah. So, you know, that's why I asked.
Okay, well, thank you all. Thank you to our participants still hanging in online. Thank you to everyone in the room for all your great questions. Thank you to our presenters. And if you did still have a lingering question, you know, they're still lingering as well. So you can come up and speak to them as well. So yes, thank you for coming. Grab a cookie for the road. Is it still raining?